Welcome to yet another class. I'm Dr. B, your chemistry teacher, and today we are going to do justice to alkenes. Alkenes are another form of hydrocarbons. Remember that we have already discussed alkenes. Alright, in our previous class we discussed alkenes, and today we are going to be talking about alkenes as another form of hydrocarbons. But remember that in this class, I always advise that you try your best to do what to share. Share this class especially to your year 1 students, share it to your year 2 students, and to every group that is chemistry or academics. Alright, now when you share it, tell them to subscribe so that they can have these videos coming up on the screens as soon as we put them on. And my Facebook page, just like the YouTube page, is Dr. B Science Classes. Right, now once you type that in on Facebook, you're going to see it pop up. Just go to where you have follow and click on follow, and then you can like, you can share and make comments. Send in your questions as comments, we will attend to them. Thank you. All right, now we're going to look at alkenes, but it's important for me to let us know that alkenes are quite a very important type of or group of hydrocarbons. Do you know that alkenes have a very sweet smell? Alright, now when you are around alkenes or you are preparing a type of alkenes, though the smell is quite faint, but they have very sweet smells. But do not attempt to do what? To inhale much of those things. They are quite dangerous. Okay, so alkenes have sweet smells. Alkenes are colorless gases. So it means that just the way you would perceiving them, you might not be able to see any color gas coming out if you are preparing alkenes, but you will perceive quite a very faint sweet smell out of that your preparation. The colorless gas, remember that when we discussed about alkenes, or rather hydrocarbons generally, holistically, we had said that hydrocarbons have different classifications, such that you can have hydrocarbons that are actually liquid in nature, hydrocarbons that are also gaseous in nature, and the ones that have low melting point solids. Okay, like paraffin wax, for example, it is a low melting solid, and it's also a form of hydrocarbon. Okay, benzene is definitely a type of hydrocarbon. Okay, that belongs to that particular liquid form of hydrocarbons, and all those that and that we had discussed last time. So alkenes are gases, colorless gases. And do you also know that they are soluble in organic solvent, just like alkenes? They are hydrocarbons. So like I said, it's not surprising to see that alkenes are soluble in organic solvent because they are organic compounds themselves. So it means that they are quite insoluble in polar solvents. Okay, but alkenes are also such that they are neutral in nature. Alkenes do not have any action on litmus. Remember that litmus paper is used to test for acidity or alkalinity, and if a blue litmus paper turns red, it means that that solution is acidic. And if a red litmus turns blue, it means that that solution is what? Is basic. Now, like alkenes, for instance, they show no action on litmus. We have said alkenes show no action on litmus. And what does that mean? It means that alkenes are neutral substances. And neutrality is checked on your pH scale to be what? To be 7. So they are not acidic, they are not basic, they are neutral. Okay, we said they are what? We said they are also, alkenes are also what? Alkenes are colorless gases. Are colorless gases. I had said that before. And we also say that alkenes has what? Has a faint, sweet smell. You have to take note of this. We also say here that alkenes are soluble in organic solvent. And finally, alkenes are also what? They are lighter than air. These are the most important properties of alkane that you need to know. Alkenes are lighter than air, which means that in the laboratory preparation of alkenes, you can collect alkenes over air. Because it means that air is denser than alkenes. than alkenes, right? Not alkenes, alkenes. Air is denser than alkenes. It means that in its preparation in the laboratory, you can collect what? Collect alkenes over air. That's what it means. And a very simple process. They are soluble in organic solvent. We have mentioned that because they are more of what? Hydrogen and carbon, so they are hydrocarbon. So it is not surprising that they are soluble. They are very soluble in organic solvent and partially or even completely insoluble in polar solvents. They have faint sweet smell. I've said that before. That is the attribute of alkenes. And then they are colorless gases. I've mentioned here that hydrocarbons generally are either gases, liquid, or even what? Or even low melting point solids. Some of them can even be classified on the basis of their polymerization reactions, where you can have polyvinyl chlorides and polyethylene. Okay, so we said they show no action on litmus, which means that alkenes are neutral. They are neutral solutions, so they do not have what? They do not possess a tendency of changing litmus, whether into blue or into red, as the case may be. Now, these are the basic properties of alkenes. You could have others, but at least you should be able to have a handful of these very properties listed here describing what? Describing alkenes. Now, do you also know that alkenes are known to be what? To be unsaturated hydrocarbons. Okay, they are unsaturated hydrocarbons. They are unsaturated hydrocarbons. Remember that when we dealt with alkanes, we said alkanes were saturated hydrocarbons because they have straight chain, they have single bonds attaching to it, or rather attached to it to their carbon atoms. So the alkanes may be branch or straight chain alkanes, but they are what? They are saturated hydrocarbons. Now alkenes are known to be unsaturated hydrocarbons. No wonder you can see a double bond that is here holding the carbon to another carbon. And they are unsaturated hydrocarbons because, like I said, they have carbon-carbon what? Double bonds. And that is one property that differentiates alkenes from alkanes. Alkanes have single carbon-carbon single bonds, whether branch or chain. Or straight chain, but alkenes have carbon-carbon what? Double bond. That is why they are known as unsaturated. Again, why they are called unsaturated is because their carbon atom is not bonded completely to 4 other atoms. Remember when we had mentioned alkanes in our previous class, we said that alkanes have its carbon atom bonded completely to 4 other atoms, and that becomes a bit difficult for them to be reactive. But the alkenes are very reactive because their carbon atom is not completely bonded to 4 other atoms. There is a possibility for any of the atoms to be displaced for any of the bonds rather to be displaced for another atom to occupy. So this is the reason why alkenes are described as being unsaturated hydrocarbons. Now, do you know that alkenes are sp2 hybridized? Okay, alkenes are sp2 hybridized. They are sp2 hybridized. What do we mean when we say that alkenes are sp2 hybridized? Remember that hybridization is simply the addition or the mixing of different orbitals. And we have the sp hybridized orbitals, sp2 hybridized orbital, sp3 hybridized orbital, s2p s2p2 hybridized orbitals, as the case may be. Okay, so when we say alkenes are sp2 hybridized, what that simply means is that there is a mixing of one of the s orbital to 2 of the 2p orbitals to form a hybrid orbital. That is just what we mean. What it means is that for the orbitals of alkenes in any compound that you have, there is a mixing of one of the s orbital to 2 of the p orbitals to give you a 3 hybrid orbital. So it is the 3 hybrid orbital that allow for the formation of alkane. of alkene. And why it is reactive is that this 2p orbital can be a px orbital plus a p or and a py orbital. So where is the pz orbital? Because if we say that alkenes are sp2 hybridized, implying that there is a mixing of one of the s orbital with two of the p orbital, which could be the px orbital and the py orbital, to form three hybrid orbitals that form that compound that you call alkene. What happened to the pz orbital? Now the pz orbital is always the orbital of reactivity. Not too specific about the pz anyway, depending on the one that actually did the mixing and the one that is left. That one that is left is the actual orbital that allows for reactivity, because it's that one that is going to do what? Undergo the excitation that will allow for what? For the reactivity of an alkene. Okay, so we say that alkenes are what? Are sp2 hybridized. Now alkenes have a homologous series of what? Of hydrocarbon, and usually they have a general formula, and the general formula of alkenes is CnH2n. Remember that the general formula of alkenes is CnH2n plus 2, but that of alkenes is CnH2n only. So the N here simply means the number of carbon atoms, and the N here, number of hydrogen atoms. So if N was 3, for example, it implies that this alkene will be C3H2 times 3. So we have C3H6. And what alkene is C3H6? Is what? Is propane. Propane, because you have ethane, okay? You have ethane, which is the ethane for the alkane. Now you have ethene for the what? For the alkenes, C2H4, and then you have what? Propane, which is what? C3H6. You have butane, which is what? C4H8. So you can possibly be able to determine what alkene we are looking at by understanding what number of carbon atoms or hydrogen atoms are there, and that you can do by getting used to what? To the general formula describing alkenes. Alkenes, just like alkenes, will always have a suffix that ends with what? ene. So anytime you want to describe alkenes, you must know that alkenes are always ending with the suffix ene, unlike the alkenes that end with the suffix what? ane. Quite beautiful. Now, do you know that there are relevance of alkenes? Alkenes are very important in our daily lives. So you can possibly have alkenes being used to ripen fruits. Okay, so alkenes can be used to ripen fruits. Okay, so ripening of unripe fruits. Do you know that alkenes are used to ripen unripe fruits? So most of the fruits that you come by, especially those ones that are mass produced, those ones that for example, let's say oranges, for an instance, you have orange orchards, orange farm, okay, and you want to do sales at regular basis. Do you know that you can use alkenes, okay, type of alkene, to do what? To spray the oranges, and they are going to do what? Ripe. They get ripe. All of them will get ripe at the same time. Within a very short time, all of them will get ripe at the same time. So alkenes are used to do what? Are used in the ripening of unripe what? Fruits. Alkenes are also used in the production of synthetic chemicals. Okay, so in the production of synthetic chemicals, you can also see the application of what? Of alkenes. For example, the production of ethylene glycol. glycol. Ethylene glycol is produced from what? Produced from an alkene. You can also see production of let me look at a common one. Let's say diethyl ether. Diethyl ether. Diethyl ether is a solvent. Usually you can use it in the separation technique, okay, to separate certain phytochemicals. Okay, so ethylene diethyl ether is another type of synthetic chemical that you can produce from what? From an alkene. Even polyvinyl chlorides and polyethylene are also synthetic chemicals you can also produce out of alkene. Alkenes, especially alkenes, especially ethene, is a very important hydrocarbon that things like ethylene glycol, diethyl ether, polyvinyl chlorides, polyethylene are produced out of, and many other types of what? Of synthetic chemicals. Okay, now do you know that there are some reactions that alkenes undergo that makes them quite unique? Okay, now there are some reactions that alkenes undergo that makes them very unique. Now one of those reactions is the addition reaction. One of those reactions is the addition reaction. Addition reaction. Addition reaction is one very important reaction of alkenes that differentiates it from alkanes and alkynes. So alkanes and alkynes do not undergo addition reaction. So basically it is a reaction that is likened or applicable to alkenes. Now for example, when you react an alkene, for example ethane, with hydrogen, okay, you are going to have an alkane which is what? Which is a saturated hydrocarbon. So you are going to have C2S6, and this itself is an alkane, basically ethane. Okay, ethane. So you can see that while this is unsaturated hydrocarbon, this is saturated hydrocarbon. You can see that. So if you react an alkene like an ethane with hydrogen, that is hydrogenation of ethane, okay, you will have ethane, which is an alkane. Now if you also decide to react this with water, okay, if you decide to add water to an alkene, which for example ethane, you are going to have ethanol. This is ethanol. Okay, so you can see that this is a typical addition reaction of an alkene. So when you react an alkene like ethane with water, you possibly can have what? Can have ethanol. Another kind of reaction that is always very common with alkenes is combustion reaction. That means that alkenes can burn in oxygen. Now, if you look at combustion reaction, of alkane, you can react an alkane C2H4 with oxygen, and this will possibly give you carbon dioxide and water. Okay, so this is a combustion reaction. So if you react an ethane, which is an alkene with oxygen, you can have carbon dioxide and water. Now these are possible reactions of alkene. You can also see another reaction of alkene as polymerization. Polymerization reaction is another type of reaction that alkenes exhibit, and it is through polymerization reaction that you can have products like polyvinyl chlorides and polyethylene, okay, from monomers of what? Of alkene, basically ethane. Okay, so these are the basic, these are some basic chemical reactions that you expect from what? From alkenes. Did you know that alkenes can be classified? Alkenes can be classified also as monoalkenes. Okay, alkenes can be classified as monoalkene, or a dialkene, okay, or a trialkene, or even a tetraalkene. And to some extent, you can also classify alkenes as trans alkenes or even cis alkenes. So you can have alkenes can be classified as either monoalkene, dialkenes, trialkenes, tetraalkenes, or trans alkenes, or even cis alkenes. Okay, so you can classify them in these various forms. And let us quickly just look at it. Now, this classification is based on the presence of an alkyl group. Okay, so if it is a monoalkene, for example, you can have, let's use an ethane molecule. So if it's a monoalkene, it means that it has only one alkyl group. And usually this alkyl group that you have here is okay, this is not too clear. So the alkyl group that you have here is maybe a methyl group, CH3 group. So if it's only one, it means that it's a monoalkene. Now for the second one, a dialkene, you can have two. Okay, you can see this is a dialkene. If it is a trialkene, it means that you have 1, 2, 3, and this hydrogen. So with the presence of these alkyl groups, which usually a methyl group at the 3 points here, bonded to these atoms, of course they bonded to the atoms of the carbon atoms, describe what? A trialkene. And if it is a tetraalkene, it means that all the bonds have been occupied by an alkyl group. So this is a typical example of what? Of a tetraalkene. Now the transalkene and cis-alkyl are basically mirror images at times, okay, of this alkene molecule. Okay, so an example of a transalkene can be, we can see a transalkene in okay, well, what is it? Okay, well, we can possibly have a transalkene. Let's put it this way. So we can have a transalkene as arrow here, okay, hydrogen. So you can see that. You can see what we have here. This is a transalkene, while a cis-alkene, can be this. The cis-alkene can be a dialkene. So this is a transalkene where the alkyl groups or methyl groups are directly adjacent to themselves, and this is a cis-alkene. This is an example of a cis-alkene as well. So a cis-alkene can be described as a dialkene. I don't want to take us too far more than this. In our subsequent class, we are going to look at alkynes. Just as I promised, we are going to look at them one by one and get through the hydrocarbons. It is now having this class with you today, discussing alkenes exhaustively under hydrocarbons. Do not forget to subscribe. Do not forget to also do what? Share this class, share it, so that other chemistry students and other science students will be part of what we are doing.